Well, happy Monday, everybody. I hope you had a wonderful weekend. Before we go on any further, I just want to remind you that on Wednesday, you will be having a test. It will be on Discovery Education, and all the details of what's going to be covered on that are in your posting for today. Okay, so please make sure that you're ready to do that. I'm sure you'll all find it rather easy to do, but also challenging at the same time. All right, so let's get into today what we call consecutive integers, which are another way of using multi-step equations to solve a problem. Okay, so let's begin with a basic definition of consecutive integers. And you'll probably, it would be best if maybe you recreated these notes in your notebook so you have them with you. And you can follow along as I do this as well. So consecutive integers are integers that in a basic definition, follow each other. Okay? So they're basically integers that come one right after the other. Okay, so if you look at our next example of consecutive integers, we have 1, 2, 3, 4. So if we look here, 5, 6, 7, 8, and of course the ellipse means and so on. These are what we call basic consecutive integers. And notice that the pattern for consecutive integers is counting plus 1. Now, if you look at the next example, it says examples of consecutive even integers. So we know we have both odd numbers and even numbers. So if we look here at these even numbers, we go -6, -4, -2. And as I continue to count up, I would get to 0 and then have 2, 4, and 6. So my pattern here is going to be plus 2. Okay? Same thing with consecutive odd integers. I count 1, 3, 5, 7. So then I'm going to have 9, 11, 13, and 15. And again, my pattern is plus 2. So notice how when I have consecutive integers, I just count by ones. And then when I have evens or odd integers, I actually skip the number in between, and I have a pattern of plus 2. Okay, so let's look at our first example here, which says to find 3 consecutive integers with a sum of 63. Okay, so we're looking for consecutive integers. So my first integer, I'm going to let x represent the first integer, because that's where I'm starting at. Now, since I'm looking for consecutive integers, my counting pattern is a plus 1. So that means my second integer would be x plus 1, and my third integer would be x plus 2, and all of these are going to equal 63. So if I go to my Canvas board here, and what I'm going to do, just so I don't confuse myself, is I'm going to have x plus 1, and I'm going to put those in parentheses, x plus 2, and all of that equals 63. And this is my first, this is my second integer, and this is my third integer. All right, so in order to solve this, I just use the steps that I normally would for a multi-step equation. So I'm going to combine my like terms. So I have x, and x. So that's going to be 3x. 1 and 2 gives me 3. And all that equals 63. So I come up with a number here of x equals 20. Okay, so if I go back to my worksheet here, my first integer x is going to be 20. Now my second integer is x plus 1. So So 20 plus 1 is 21. And then my third integer is x plus 2. All right, 20 plus 2 is 22. So if I were to add up 20, 21, and 22, I get 63. Now, I know some of you out there might be saying, well, I could just figure that out by myself through another different method. And that's well and good, but that method is not going to work all the time. So we need to have an algebraic way to solve these. And that's what I'm giving you today is an algebraic way to solve it. Okay? And this is the way that I want to see you solve these. So let's go on to the next one, which says find 3 consecutive even integers with a sum of 42. All right, so same thing is my first integer, I'm going to let be represented by x. Now for my second integer, all right, let's go back and look at what our counting pattern is. Our counting pattern is plus 2. Okay, and what you need to think about is if we drew a number line over here, and here's 0 on my number line, which is an even integer. 1 is odd. 2 is the next even integer. So there's x, x plus 1, x plus 2. So my second even integer is x plus 2 because I have to skip the integer in between. So then if I'm going to get to my next even integer, there's x plus 3. So that gives me x plus 4. And all of that's going to equal 42. Okay, so hopefully you can understand that the reason you're going plus 2, plus 4, plus 6, if we were continuing to go, is because you have to skip these odd integers in between, because you're looking for consecutive even integers. So let's go ahead and set this one up. I'm going to have x plus 2 this time, plus x plus 4. And all of that equals 42. So there's my first, my second integer, and my third. All right, so same thing. I'm going to solve this like I would solve a normal multi-step equation. So I don't have anything to distribute, so I'll combine my like terms. So I have x, x, and x. So I have 3x. 2 plus 4 is 6. And all that equals 42. So if I subtract 6 from both sides, and so I have x equals 12. So that would mean my first integer is going to be 12. Now for my second integer, that's going to be x plus 2. So x is 12. X plus 2 equals 12 plus 2, which equals 14. And then my third integer is x plus 4. So that's going to be 12 plus 4, which equals 16. So again, if I were to add all these up, 12, 14, and 16, 12 and 4, 2 and 4 is 6, plus 6 is 12. Carry a 1, 1, 2, 3, 4. My answer is 42, which is exactly what we said over here. 3 consecutive even integers with a sum of 42. All right, so let's do our last one together, which is the 3 consecutive odd integers with a sum of negative 21. So again, my first integer I'm going to let be x. Now, same thing here. If you think about this on a number line, if I start at 1, here's 2. What is my next odd integer? 3. So again, this is going to be a +2 counting pattern. Here's 4. Here's 5, my next odd integer. So again, that would be adding 2 more from 1 to 2, so that would be a +4. Because remember, you have to skip, in this case, the even number in between. So we're going to have x plus x plus 2 plus x plus 4 equals a negative 21. All right, so again, here's my first, my second, and my third for the 3 consecutive integers. So x plus x again is going to be 3x. 2 plus 4 is 6. All of that equals a negative 21. Now, when I subtract 6 from both sides, and it's very important to understand your integer rules here or else you're going to get the wrong answer, 3x equals negative 21 minus 6, which is a negative 27. Divide both sides by 3. So I get x equals a negative 9. So that means my first integer is negative 9. So negative 9 plus 2 equals a negative 7. Oh, excuse me, that should be a 4. I'm sorry, that should be a 4. So negative 9 plus 4 is going to equal negative 5. So if I were to add all these up, negative 9 plus negative 7 plus negative 5. Well, negative 9 plus a negative 7 is a negative 16. Negative 16 plus a negative 5 is going to equal a negative 21. So those there are my 3 consecutive odd integers with a sum of negative 21. Okay, so it's really important as you do this to remember your math vocabulary that sum means addition, which the problems that I'm giving you today are all going to be sum problems. All right, so if we go over, here's your Canvas assignment. It's the Solving Consecutive Integers Problems maze. Okay, you're going to find the path from start to the end. So as you find the correct answer, just look for where that correct answer is, and then that will lead you to the next box to solve the next problem. And you solve the problems all the way till you get to the end. So please include a copy of your calculations for me as you do this. And if you have any questions, as always, I am on Google Meet, or you can email them to me, and I will be glad to help you out. So have a great day, everybody. Thank you for all that you do. Thank you for having such wonderful attitudes out there in the